Hi, my name is Andrew McLaren. Today we're going to be talking about Celsius and Fahrenheit and converting between the two, as well as how to make these conversions a bit easier using a bit of simplified math. So the big trick on this is that you want to think about your boiling point and your freezing point and what those are in Celsius as well as Fahrenheit. If you know those numbers, then you can make these formulas pretty easy. Most students will know, like, oh, the Celsius, that's going to boil at 100 degrees Celsius and freeze at 0. For Fahrenheit, most people will be able to identify the freezing point at 32. But if you can also get the boiling point at 212, then it's going to make this pretty easy to do. Now, if you don't know that one, if you follow through to the end of the video, you'll see actually the kind of the relationship simplified, so it'll be easier to memorize that 212 number. But just bear with me for a little bit to get to that. We're just going to assume that you have that value for now and work on getting the formula. So this is, in a sense, you've got like your x and y values here. And you can think about this as a y is equal to mx plus b. If you remember, if you've got 2 points, like you should be able to make the formula from those 2 points. There's a couple different useful things that we can do here, like finding the slope. So for example, the slope m is going to be the change in y over the change in x. And we're going to be going from Celsius being the x to Fahrenheit being the y for the first version of this. It's easier. It's a more common formula that you're going to see where you've got this F times C times some sort of ratio plus another number right here. So if we're looking at getting the slope, that is going to be using our 2 data points. But I'm just going to remind you really quick that for Fahrenheit and Celsius, when you have 0 in for your Celsius, you end up getting 32 for your Fahrenheit. So this number right here doesn't really matter because whatever it is times 0. So our B value for this formula, when we're solving for Fahrenheit as our Y, needs to be 32. Because this whole thing kind of gets simplified. So the B value here is pretty easy. It's just 32 because we need to add that in when you've got 0 degrees Celsius. If we're going back to the slope though, if we've got our change in y over our change in x, you can do your 212 for your y value minus 32. And then for Celsius, we are at 100, and we can subtract 1 from that, and we get 180 over 100. Now you could do this the other way around. You could have the 32 minus the 212, and then have the 0 minus 100. You get the same value, it's just negatives. So you could have the negative 180 over negative 100. In both cases, these simplify down to, you could think about this as 18 over 10 or 9 over 5. And so that's our ratio that ends up going into the formula here. So in other words, we've got our Fahrenheit, which is equal to 9/5 times Celsius plus 32. This formula is going to be pretty useful, and you're going to see that more times than you're going to see the other way around. You could get your Celsius equal to some number times Fahrenheit plus some other number. Probably the easiest way to do that is rearranging what we have solved for when Fahrenheit was the y. It's a bit weird to do it from the other values because we don't have our b intercept so easy, because like 32 gives you 0, and that works out nicely when we're arranging it this way. but the other way is a bit tricky. So to get this by itself, then say that you're subtracting 32 from both sides. So we've now got Fahrenheit minus 32, which is equal to 9/5 Celsius. Then you can multiply both sides by 5/9 to get Celsius by itself. And that's going to be a bit weird because now we're going to have to cancel some things out. So the C is now canceled out because if you multiply it by a reciprocal, if you have the 9/5 times the 5/9, that ends up being, what's that? 45/45, which is just 1. So that gets the C by itself. That's kind of why we're multiplying by that. But now you've got the 5/9 times Fahrenheit minus 32. So we've got to multiply everything by 5/9. So yeah, you've got 5/9 Fahrenheit. But then you're going to have to multiply that 32 by 5/9. Times 5 divided by 9. We get 17.778. And so we do have our C value here being equal to 5/9 Fahrenheit minus 17.778. If you were doing sig figs, it's gonna be a bit different, but that's the big picture on the formula that way. So the easiest way to think about converting between these two, this trick, is to use multiples of 5. Sorry, there we go, multiples of 5 for Celsius. And that's going to end up just making the math a bit cleaner and easier for you. So if someone was telling me, oh, it's like 21 degrees Celsius, and I'm like, what is that in Fahrenheit? I'm just going to round it down to 20. So let's say that I've got 21 degrees Celsius. Let's just assume that that's about 20. And we can take our formula we had here earlier, relating Celsius to Fahrenheit, and just plug in our value. So now we've got 20, and that's going to be times 9/5. And because it's a multiple of 5, this works out really nicely. In this 5/9 times the number part of the formula. So if I've got my 20/5, ends up being 4. So we could multiply 9 times 20 and then divide that by 5. But you can also just think about this as like 4 times 9. So that ends up being 36. So I've got 36 plus 32. And that ends up giving me about, what is that? 68 degrees Fahrenheit. So this is like cool day. It's like around room temperature, maybe a bit lower, higher, depending on what you set your temperature to. But 20 degrees Celsius is a pretty comfortable temperature. Now, if you wanted to go to, let's say it was 29 degrees Celsius, I'm just going to round that to 30 degrees Celsius and plug that into the same sort of formula. So I've got Fahrenheit, I've got 9/5, I've got 30 here, plus 32. Now 30 is 6 times 5, so now it's just 6 times 9. In other words, I can do 9 times 30, get 270, divide that by 5, and I get 54 plus 32. So this is going to be 86 degrees Celsius. So it's a fairly warm day. It's not like that hot when it's 30 degrees Celsius, but 40 is like pretty darn hot. That's not going to be super comfortable. Now going back to how do I memorize this number that we were working with earlier, that 212. Well, if we know that we've got that 9/5 times my Celsius right here, plus 32, that's going to give me my Fahrenheit, what you can do is see that if I've got 100 and I've gotten the 9/5, well, 100 is a multiple of 5. It's actually 20. So this is going to be 9 times 20, which is 180 from those two. And we've got to add the 32 to that. So you've got 180 plus 32, which is going to be your 212 degrees Fahrenheit. So if you're able to see the multiple of 5's trick, then plugging in 100 degrees Celsius ends up kind of canceling out that 5 in a nice way, leaving you with just 20, multiplies up to 180, and then you just add the 32 on top of that to get to the 212. So for some time I was like, is it 212 or is it 218? But then when I saw this trick, it helped me remember that it's pretty nice and pretty clean when you have multiples of 5, which the boiling point of water is actually at. So it works out pretty cleanly.